at a later date. And Nehemiah, when are we taking our test bed? I thought it was yesterday, but you didn't come in. During class? Oh. Okay. I was thinking it'd be like during period 7 or something. Does that work? Or is practice during period 7? Do you want to try? Okay. I figured you could focus a little bit better. If it works. If it doesn't, then we'll just do tomorrow in class. Be ready, though. I don't want it to mess you up. Okay. Odd than even. Number 6. It was a little bit messy with the fractions, right? Well, it wasn't too messy just to steal the y and steal the x. Did you guys notice something kind of cool, though? What happens when you put an over 17 over another over 17? Do you guys know what I'm referring to? What trig function needs you to take one and put it over the other? Tangent. Yeah, tangent and cotangent. So let's just use tangent as an example. Because wouldn't you guys have needed to do 15 seventeenths all over negative 8 seventeenths? This freaks a few of you out, and that's okay. I get it. But pause. He has a 17th, and he has a 17th. Let me show you, yes, true, but just to show people why, because just from years of experience, just telling them cancel out doesn't always work. This guy is a 17th, and this guy is a 17th. I could technically separate and say they both have 17ths. Negative 15 eighths. In my head, I just see 17th, 17th, yay, reduce. But that's technically how. But some of you still went back to the good old-fashioned, when you divide fractions, what do? Multiply by the reciprocal. Would that have also worked? Yeah. Whether you think of it my way, whether you think of it as the 17th is there and gets to go away, or whether you think of it as multiplying by the reciprocal top times the reciprocal of the bottom, all the ways work. My people that freak out with fractions, do we get this? Okay. Okay. Keep going. Number 18. This is one where you guys had to go find the point. Did anybody have any difficulties finding this point? What'd you do with if? Which direction did you go? Down. Down how much? A whole calzone and a little bit more. A third more, so maybe more than a little bit, right? So go 3 pieces, I know. Go 3 pieces and then 1 more. True? And that ended up in the second quadrant. Second quadrant has a negative x and a positive y. And in my head, it's negative, well, for you guys, it'd be this way. Negative a little, and hence the smaller number and the bigger number, x and the y. And then do you see how the 2's just reduced using what we just did? The halves go away. Done. Number next one. You guys are supposed to find all 6 of this one using the point negative 1, 0. And what was weird with the 0? Some things ended up being undefined, because what can't we divide by? Got it. Got it. Number 40. This is even and odd got real. Did it trick you? I said at the end of yesterday that even and odd properties will show up kind of randomly. And they said, we'll give you this guy, so tell us that guy. You needed to know that's even, so it's the same. Yay, steal it. That's even, so it's the same. But it's not the same as cosine. Isn't it the... Got it. Stays the same, but becomes the reciprocal. Is that the last even? There's a lot of blank space. Oh, it must be a big problem. Let me give you guys a second. This one was kind of a conceptual one, so you didn't necessarily write like huge paragraphs to answer it probably, right? They were asking whether or not different functions existed. Oh, I just closed what I was trying to open. They were asking whether or not different functions existed. And they didn't give you the exact point, but they did give you a location. Guys, look at what you wrote down. What quadrant was that point in that they were having you look at? Wasn't it the point in a quadrant, if I'm thinking of the right thing? It was a picture? Oh, it wasn't the third quadrant? Okay, that's what I was looking for. I'm trying to get the picture up on the screen. Except it's taking forever. It's going a lot better than I would, but still. Okay. There we go. Number 60, right? Yeah, it was in the third quadrant. And didn't we just talk about things will only be, trig functions will only be undefined when you're dividing by 0? Hey kiddos, if the point is right there, is anything 0? Because when is the only time that zeros will occur? Did you figure this out in the unit circle? When it's on an axis. Good. Y is 0, x is 0, y is 0, x is 0, right? So nothing's 0. Well, if nothing's 0, is there any problem plugging into my x or y or 1 over x or 1 over y or x over y or y over x? No. So therefore, do they all exist? Yeah. How come? Nothing equals 0. That's the easy form. I mean, they wrote that whole paragraph, but sure. Not x isn't 0 and y isn't 0. Everything will exist. But letter B, what were they asking?
Whether each of the functions will be positive.
Yeah, the sign just means positive or negative. Of all 6 of the functions, well, hold on. What's that little trick to know what the signs are of the functions in a certain quadrant? All students take. What's the T stand for?
Positive.
Tangent is positive. Oh, okay. So sine's negative, cosine's negative, so only tangent is positive. 6 functions, tangent is positive, but who else? Cotangent, good. So tangent and his reciprocal, tangent and 1 over tangent. If tangent's positive, 1 over tangent will also be positive. So tangent and cotangent positive, the rest negative. Why? Because in the third quadrant, you could either explain our trick and how we memorize it, or you could have said x is negative and y is negative. Everything will be negative except for the formulas that use x and y. With that, I think now we're done with homework, right? As far as checking the evens. Okay, do we have questions on the odds? Going once? Going twice? I think Mr. Richmond has a tape measure out there. I'm hearing like, anyway, sorry. Distracted. Any odds that we have questions on? Going once, going twice, and sold. Why do I do it fast? You post it on Google Classroom. You should already know what questions you have and be ready to whoosh. Cool? Okay, so we're moving on. There are just a few of you, and guys, I don't mean to beat a dead horse. Like some of you are like, you say the same things over and over. I just graded homework spirals for chapter 3 just a little bit ago, right? I had to take off points of people's homeworks because they were blank. Not the whole homeworks, but they didn't fill in a whole homework question. Should there be any excuse for having a blank homework question? You try it in Google Classroom, maybe you get stuck and you put a question mark, but what do you do the next day? Yeah. And if you're not courageous enough to ask in class, what can you still do? Just come find me and be like, okay, and I'll help. Does that make sense? Don't let me take off points from your homework. Ask the questions that you have. Just because you didn't get it by the time we graded homework doesn't mean that you have to stay that way. I think we're okay on even odd. Aha. I think we're okay on even odd, but real quick, can you guys go to the back of your homework spiral? Sorry, did you all put it away? I got distracted with the whole, I'm a little worried some of you don't ask the questions that you have. I'm just trying to help, but I can't help if you don't let me. But I distracted you guys. Back of your homework spirals. Here's what I want you to do. I want you, yourself, and you, without looking at your patty papers, to make your best guess for the following 3. I want you, yourself, and you. No collaboration, not yet. To make your best guess for the following 3. And let me remind you just of one little thing on the board to inform your guessing. Because if I were you, I would want to at least know what different things I should be guessing from. So remember in the unit circle that x and or y will only be the following numbers. 0 or 1/2 or root over 2 or root 3 over 2 or 1. It's one of those 5 with a positive or with a negative. As you guys are writing down, doing your best guess, some of you are like, I'm solving it because I'm smart. Perfect. But if some of you have to guess, remember, the x's and the y's come from those 5 numbers with either a positive or a negative. So if nothing else, for number 1 and 2, you have a 20% chance of getting it right. Well, of getting the right number. A couple more minutes.
Are we just finding the order here, or are we finding the simplified function?
You're just finding the sine of, the cosine of. So you're not finding all 6, you're only finding 1. So for number 1, of 4 pi over 3, just what is sine? For number 2, of 11 pi over 6, just what is cosine? And for number 3, for 3 pi over 4, just what is tangent? You can think you get a point just for getting the right positive or negative. And then you get the second point for getting the right number. Okay, one more minute. The best guess you can. Worst comes to worst, for 1 and 2, you should be choosing one of these numbers, a positive or a negative. Who's pretty sure they have number 1 right? Priscilla, what do you got? Someone want to agree or disagree? Good.
I disagree.
You think it's good?
I disagree.
Okay. The first one I heard was Wesley. Why disagree? Is the unit circle? Where is 4 pi over 3?
It's in the 3rd quadrant.
Good.
And it's
A larger angle? Is that okay?
Yeah.
Okay. And Wesley, do you think of adjacents and opposites, or do you think of x's and y's?
I think of X's and Y's.
Okay, cool. So sine goes with what, the x or the y? Good. And the value would be, so Priscilla, good job on the negative. You were totally right. 3rd quadrant, sine would need to be a negative value. Yeah, yeah. So, thanks, Wesley. Oops, sorry. These are skinny. Can anybody think, once you get the location, hold on, how did Wesley know it was in the 3rd quadrant? How could we think of this angle? It's over 1.
It's 1 calzone and then some.
1 calzone and then some. 1 calzone and a little baby piece, a middle piece, or a large piece?
Little baby piece, mid large, but it's not as large as
Okay. Okay. If you're thinking about which of these middle three, it's either a baby piece, which is a sixth, a middle piece of a half, which is a fourth, or a larger piece. Doesn't mean your brain has to think that way, but try to. A large y, a middle piece with the same x, same y, or then a large piece with a little x, big y. The reason I'm saying that is Priscilla was at the right place, just she couldn't remember which one's which. And some of you were like that too, in the sense of the x is littler, smaller, and the y is bigger. Oh, and they're both negative because of the third quadrant. Dun, 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 dun. Pause. Did anybody convert to degrees? Just curious. Okay. Okay. If you convert to degrees, you would have ended up, Joe, where was this?
Like 60 over 180, so it's...
Plus?
Yeah, 60 plus 180.
So go 180 and go 60 more, so it was 240. Just in case some of you are like, oh, if I had converted to degrees, I would have known where it was. Maybe some of you need to do that. But 1 1/3 calzones, I don't know, for my brain it works. Maybe, maybe not for you. Speaking of the same thing, number 2. Who has, raise a hand, don't tell me an answer, raise a hand. Who's pretty sure they have the right one? Jason.
Positive square root 3 over 2.
Someone want to agree or disagree?
I agree.
Agree? Okay, then Jason. Why?
So I thought of it as the closest angle to the 2 pi.
Mm-hmm.
So then I knew that it was a large x and a little y.
Mm-hmm.
And that the y was negative because it was below the axis and the x was positive.
And cosine goes with which one?
Cosine goes with the x.
Good. He's totally right. Joe, you're doing a good job, just you got the Snickers bar, so I'm trying to give other people a chance. But good job. Over a lot, down. Wait, how did Jason figure out 11 pi over 6 was the closest one to 2 pi? It's almost 12 pi over 6, right? If you have 11, if they're cut into sixths, wouldn't that be 6 and that would be 12? Oh, short by 1. X is big, the y is little, the x is positive, the y is negative. Dun, 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 dun. I need the x. Number 3, who's pretty sure they have an answer? Chris?
Negative.
Ooh. I'm going to have you go straight to explaining it because you're totally right. How'd you think about it?
I don't know, because like, okay, so if it's in 4,
Yeah?
it would be 3, so it's like, it's half.
Good. Of this quadrant, right?
Yeah. I
Good.
just remember that it's
Like
square
3/4.
Yeah, I remember it's square root of 2 over 2, and then negative square root of 2 over 2. Then you just divide.
Yes.
Pretty much just cancels out.
Good. I'm going to change one thing. It's actually a negative and then a positive, but it turned out being fine. Why is it the other way around? Think about the point.
Oh, okay.
You go x,
Oh,
and then y. But yeah, it worked out perfectly. He remembered that pi over 4 is r root 2 over 2 root 2 over 2. The other way of thinking about it is it's over and up the exact same amount. It's not the one that's down low. It's not the one that's up high. It's the one that's in the middle. They're the exact same. Except in the second quadrant, I need one to be negative, and specifically I need, that just looks like it's attached again. This is a struggle. Attached. I give up. Anyway, the x is negative, the y is positive, but what's another way? So far, I think almost all 3 of the guys have kind of either gone back on having the point memorized in some way, shape, or form, or actually thinking about moving there, going left, going down, going right, going down. But some of you, it might be easier just to kind of know what the numbers are and then think who is positive? Students. Sine's positive, not tangent. Does that make sense? Or in this one, all students take tangent's positive, not sine. Or all students take calculus, cosine's positive. Oh yeah, he is. Dun, 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 dun. How many people got at least 1 right? Keep your hand up if you got 2 right. Keep your hand up if you got all 3 right. Ooh. I have a few unit circle masters in here, but for some of you, either you need more work on the circle or you wish there was another way. We'll come back to this page. Let's start here. Right triangle trigonometry. Either, some of you need to get better at the circle. You actually like it. It will make sense, the most sense in your brain. But some of you wish there was another way. Well, let me show you one. So I'll show you one in context of us going over section 4.3, because section 4.3 says, hey, you know what? This trigonometry thing kind of applies to right triangles. Maybe I shouldn't say kind of. Really applies to right triangles. That's actually the first time you saw it was in geometry. In Algebra 1, you might have asked your teacher, what's that sin button? But in geometry is when you learned SOHCAHTOA. In Algebra 2, maybe you learned CHOSHIKAO. Mr. Chase stole it from me, but it's okay. Just kidding. He might have used it on his own before. It's a good way of remembering it. Only for Precalc. But it's because I was teaching it before he was, and so he has to do statistics in Algebra 2. He makes it his own. In his own unique, dry humor sort of way. Triangle. Triangle. Can't we technically do like a little ABC sort of thing? Why am I naming it ABC? Aha, Pythagorean theorem. So there's always this underlying a squared plus b squared equals c squared relationship that we hopefully know pretty well. Every now and then we'll forget it and need to be reminded of it, but hopefully for the most part. We know a squared plus b squared equals c squared. However, there's a lot more in a right triangle than just Pythagorean theorem. There's also a relationship between the ratios of any two sides and the angle that's either opposite or adjacent to those sides. So for sine, we could go ahead and say that sine is equal to b over c, and we could just memorize that. But it was a lot nicer when we put little names to these guys, and we said that b was also known as the opposite side, and c was known as the hypotenuse side, right? So then we could just say opposite over hypotenuse, which is why some of you guys remember sine as so. S equals O over H. S equals O over H. Now I'm going to change this just a little bit. You ready? Just a little bit. I'm going to erase the A, B, and C. And I'm going to change it to X and Y and R. Huh. Wonder why she changed the letters. A, B, and C is what we always use. A squared plus B squared is C squared. Weren't we just talking about points? And those points had X's and Y's, and the X's were how far over and the Y's were how far up or down? So even though we used to learn it with A and B and C, we can still learn it, or we can still use it with other letters, and specifically with what we've been doing, maybe. Radius. So instead of using B over C, maybe I'll use X over R. And for the unit circle, what's R? For the unit circle, R is 1. Now, in our homework, it's not all going to be unit circle. Oh, why would it be Y over R, Matthew? Good. I replaced the wrong letter. Now, when we do our shortcut, we have so. Sine goes with opposite over hypotenuse. What comes next? Ca. Adjacent over hypotenuse. That's our cosine value. Let's do one at a time, but yeah. Adjacent over hypotenuse. You guys have already finished it off with opposite over adjacent. So we could fill in the rest of our SOHCAHTOA, the rest of our letters. Tangent, opposite over adjacent, cosine, adjacent over hypotenuse, sine, opposite over hypotenuse. We have x over r being our cosine, y over x being our tangent. And this totally lines up with the table that we just did, guys, with sine being y because radius is 1 in the unit circle, cosine being x because radius is 1 in the unit circle, and tangent being y over x, both over r. It says, hey, I'm going to flip who? Sine. Secant says, I'm just going to flip cosine. And cotangent says, I'm just going to flip tangent. And that's where we get cosecant equals hypotenuse over opposite, cho. Secant equals hypotenuse over adjacent, sh. And cotangent equals adjacent over opposite, cow. Sokotoa chosha cow. Is the entire point of section 4.3 to learn another way of the unit circle? No. The entire point of section 4.3 is not to learn another way of the unit circle. That's just something nice that happens in the midst of it. It's actually just to go back to another way of thinking about sine and cosine and tangent using Sokotoa, Chosha, Cow, and actual right triangles. So we have our Sokotoa shortcut that might help. We have our Chosha, Cow shortcut that might help. But more specifically, we have these actual right triangles with ratios that we might need to deal with. Some of you guys might still be writing. Probably most of us are done. So let's go ahead and face a kind of weird problem. Face a kind of weird problem. This problem is not in the unit circle. You might be like, what? Why not? Sine's in the unit circle. Yeah, but remember which signs were actually in the unit circle? Sine can equal 0, sine can equal 1/2, sine can equal square root of 2 over 2, sine can equal square root of 3 over 2, sine can equal 1. These are the ones that we know and we can find in the unit circle, positives or negatives. But the circle is solid. The circle connects. There are other numbers in between each and every one of these, like 0.6. Where would 0.6 fall? That's 0.5-ish, right? We'd probably guess it would fall somewhere in here. Maybe we don't know for sure. Somewhere in here. Somewhere more than 30 and less than 60? I don't know. How on earth are we supposed to solve this for cosines and tangents if we don't have an x and a y? If we use the idea of sine equaling opposite over hypotenuse, wait, can't I make this 6 over 10? Or, even better yet, 3 over 5? Why would I rather have a 3 and a 5 if I go to a triangle? Because if I label my opposite as 3 and my 5 as hypotenuse, isn't there something new, special from geometry that you guys learned about triangles? Yeah. 25 minus 9 will always be 16. Square rooted is always going to be 4. We can always fill in 3, 4, 5 triangles. It's called a Pythagorean triple. But you could have also done Pythagorean theorem saying C, he's a leg. I don't think we call him C. We call him like A is equal to the square root of 5 squared minus 3 squared. You could do Pythagorean if it wasn't as pretty as this one is. But let's say we were able to fill in our triangle. And they ask us for cosine and tangent. Once we have the triangle, should that be hard?
No.
No. Because if I want cosine, who's theta? I don't know. I don't care. They don't care. They just want what cosine equals. Okay. Tangent of theta. Who's theta? I don't know. I don't care. They're not asking for theta. They're asking for what the ratio is. So what's the ratio for cosine?
4 over 5.
Adjacent over hypotenuse. And what's the ratio of tangent?
3 over 4.
3 over 4. Opposite over adjacent. So if they give you something weird, see if you can write it as a fraction. Because if you can write it as a fraction, then you can match up. Now there is something crazy in geometry, which is really helpful right now. Because technically the size of a 3, 4, 5 triangle is much different than the size of a 6, 8, 10 triangle. The size will be very different. So if you saw the 6 over 10 and 3 over 5 and we're like, wait a minute, how are you using the smaller one, not the bigger one? The cool thing with geometry says, as long as the sides are proportional, which they are, similar triangles, the ratios will be the same. So the ratios will be the exact same. If we did a 6, 8, 10 triangle and we did adjacent over hypotenuse, it would reduce, 8 over 10 would reduce to 4/5. And if we did a 6, 8, 10 triangle, we did opposite over adjacent, we'd have 6 over 8, which reduces to 3 over 4. So they would still work, whether you use the 6 and the 10 or the 3 and the 5. So that one, not unit circle. You couldn't have done it with the unit circle, but the idea does apply to the unit circle. Special triangles. I actually have this page over here. Let me see if I like it better. Not necessarily. I think this is enough. Mr. Richmond introduced it for today. Wasn't even planned. No, I didn't even see him today. I knew he was building the light thing, but I didn't know he would come asking us a question. Have you ever been to the LA Zoo lights? Anyway, there's like with PVC pipe, there's like a canopy, and they just string tons of Christmas lights, and so you're walking through like a light tunnel of just tons of Christmas lights. All the lights are out. It's like a cool photo opportunity. Anyway, so he's making the 140s hall into a big old light tunnel that people can walk through, and then Santa will be at the end, I think. Huh? He's going to try to have it up because doing it that night is hard. The animals aren't really out when you go for zoo lights. It's more animations. But I do kind of agree, except some animals are bred in captivity, and not really sure you should go plop them in the middle of Africa. They wouldn't. Coming back. We have our 30s, our 45s, and our 60s, which correspond in our unit circle with 90s and all of them, Joe. So I guess I could just say 90, 90, 90, 90, 90 a lot of times, or just say the other special angles. Right triangle has 90 degrees. Yeah, there you go. There you go. I understand. Special triangles. But see, when I keep on saying within the quadrant, I mean not the axes. Does that make sense? For our special triangles, we have 45, 45. With, as we saw today, x and x root 2. For our 30/60s, across from our 30 is our x. He's our smallest angle, and he's the 1x. Across from the 90, aka the hypotenuse, is the 2x. And in between the 1x and the 2x is a number that's a little bit smaller than 2, but it's going to be x root 3. Some people just say it's the 1, 1, root 2 and the 1, 2, root 3 triangles. They're not wrong. But we put the x's in to say that the sizes might be different, that whole similar triangle thing again. But here's what I want you to see. Yes, this works for geometry, and yes, this works for ratios. But I could apply this to the unit circle and say, okay, unit circle. I could say pi over 4 and pi over 4. Anytime I have an over 4, I could use the ratio of 1, 1, root 2, just using the most basic. Oh, it doesn't work. Unit circle has a radius of 1. So the hypotenuse can't be this, but I can scale back any triangle to be a similar triangle of smaller size by just dividing every piece by the exact same unit. So I could make it a unit circle value by dividing everything by root 2, and guess what? This geometry triangle becomes 1 root 2 over 2 root 2 over 2. Oh my goodness. Unit circle, and there's the x and y that goes with any over 4. It's really just an opposite and an adjacent. And we could do a very similar thing with this guy. And the unit circle, he might appear like this at a pi over 6, or he might be flipped at a pi over 3. But the ratios are still the same. Across from the pi over 6, I have a 1. I have a 2, then I have a root 3. It's as basic as it can get. Oh, the radius is 2. That doesn't work. So scale it back and divide everything by 2. I have my ratios for my pi over 6, and if I was to flip this just a little bit, I'd have my ratios for my pi over 3. You could go back to geometry. And this is where some of us are saying, hey, it's a little, hey, it's a lot. I mean, yes, you could just memorize it's these 5 special possible values of x and y, or you could say like, oh, hey, that comes from across from the 30 in a special geometry triangle, or across from a 60 in a special geometry triangle. Now the cool thing is, this is how we would take these triangles and scale them back to be in the unit. This is how we could scale it back. But actually, to solve the unit circle, you don't necessarily have to scale it back because the ratios will be the same. So for instance, let me show you using triangles how some teachers teach the unit circle without having kids ever memorize the actual x's and y's like we were working with in section 4.2. Give me one of the ones that we did earlier today. Didn't we do sine of, was it 4 pi over 3?
Yeah.
Okay. You still have to figure out for any of these what quadrant, otherwise you won't know positive or negative. We already talked about how this is going to be in the 3rd quadrant because it's 1 1/3 slices. But if you could figure out that if it's in the 3rd quadrant, you're really just looking at, technically you'd have to go a little bit farther, but you're really just looking at a pi over 3 triangle with a square root of 3 and a 1 and a 2. You'd have to remember, oh, hey, x is negative, y is negative, but you could actually put a triangle in there. See you later. You could actually put a triangle in there. Now, it wouldn't necessarily fit in the unit circle, but that's okay. And then you can say, hey, what's the opposite over hypotenuse? Oh, of course sine is negative root 3 over 2. Dun, 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 dun. What if you needed all 6? Oh, easy. Adjacent over hypotenuse, opposite over adjacent, hypotenuse over adjacent, hypotenuse over opposite, adjacent over. You could use this to find any of your 6. Now, using triangles doesn't necessarily help you do the unit circle fast. But if you can find the correct position in the unit circle, either this triangle, that triangle, or this triangle, that's not a very right triangle. Sorry, guys. It's a little messy. One of these triangles will fit. And so you could actually use geometry the right spatially work a little bit easier for you. You still want to think of 1 1/3 calzone, but put in a right triangle. Just remember, you still need to think about the sign. And there's always the fail-safe of all students take. Tangent is positive, sine is not. That could be a double check that you have the right one. Now, this section is not entirely, remember, unit circle. This section is not entirely unit circle. There are some other things that come into play, really just being introduced. It's not being taught totally yet. But in this section, it's like, hey, you just saw that right triangles have something to do with trig, or you just remembered that right triangles have something to do with trig. As a result, let's start reminding you of some formulas and some relationships that are true. So you guys are going to get this down in your notes so that we can start off class with this tomorrow. This homework isn't due until Friday, but we're not going to take all of tomorrow on it. We're going to do some unit circle practice also. So it's not a bad idea if you guys practice the unit circle a little bit more. We do have a unit circle quiz a-coming right around section 4.4. We do have a unit circle quiz coming right around 4.4. Probably right at the beginning of next week. On chapter 4, we're also doing a mid-chapter quiz, kind of like we did for, what was it, chapter 2, I think? 2.1 to 2.4. Remember, it wasn't a huge deal as far as tons of questions in this like whole class time long quiz. But it did give you a chance to kind of take a break, study what we've done so far before we move on. We're doing that in chapter 4 as well, just to give you a heads up, okay? So next week, both the unit circle quiz and a 4.1 to 4.4 quiz. If you guys want to grab a picture of it on the way out, you totally can. Just have these formulas ready in your notes tomorrow for us to finish off 4.3 and say, okay, how are we supposed to be using these things? And we'll develop the unit circle a little bit more.